Good day everyone. Today I will discuss about kNN. So first of all, what is kNN? kNN or k nearest neighbor is one of the most simplest supervised machine learning algorithm, mostly used for classification, as it classifies a data point based on how its neighbors are classified. So basically, in kNN, we classify the unknown factor with its nearest classified neighbor. K in kNN is a parameter that refers to the number of nearest neighbors to include in the majority voting process. For example, in this graph, we want to know if the shaded mango is ripe or raw. But before we proceed, we need to identify what are these yellow and green mangoes are. So in this example, we can see that the yellow mangoes are high on the level of softness but low on sourness, which means they're ripe, while the green mangoes are high on the sourness but low on the softness, which means they're raw. So with kNN, we need to set a parameter for k. For this one, we will use 5 as the k, which means we will get the first 5 nearest neighbors of our unknown. So in here, we have the 5 nearest neighbors of our unknown. It consists of 4 yellow mango and 1 green mango. So because the majority is yellow mango, we will identify our unknown as yellow mango, which is ripe. Simple, right? Now, the question is, how do we choose the right parameter for k then? So again, kNN algorithm is based on feature similarity. Choosing the right value of k is a process called parameter tuning, and is important for better accuracy. For example, in this picture, we will try to identify the unknown object, if it's square or triangle. Now, if we use 3 as our parameter for k, we can identify our unknown as square, because the majority of its neighbors are square. But if we use 7 as our k, our unknown then becomes a triangle. So with that, as you can see, choosing the right parameter for k is really important. If your k is too low, like what happened to the example, the result might not be accurate. But then, if your k is too high, then it will take too long to process, and in programming, it might lead to processing errors. So once again, how do we really choose the parameter for k then? Well, as what we have searched, the most common method used for choosing the parameter of k is getting the square root of n, or getting the square root of the total number of objects. And if the result is even, you might want to add or deduct 1 to it to make it an odd number, which is to prevent a draw in voting. Now, how does kNN works? Well, in kNN, you can't just use your eyes alone to measure which are the closest neighbors of the unknown. You also need to use math. And so, we will use the Euclidean distance formula to know which is the nearest from our unknown. The formula for Euclidean distance is d is equal to square root of x minus a squared plus y minus b squared. So for example, we have this set of labeled data. So we have 2 variables which are weight and height, and each point is classified as normal or underweight. Now, this is our unknown. We want to find out if this data is underweight or normal using kNN. So to understand it better, we will try to solve this using Euclidean distance formula. So we will try to calculate the Euclidean distance of this one. So d1 is equal to square root of 170 minus 167 squared plus 57 minus 51 squared, which is equal to 6.7. And so we will get the Euclidean distance of the other points just like what we did with this one. Now, assuming that we already calculated every distance of the points and we will use 3 as the value of our k, now we just need to get the first 3 that has the lowest Euclidean distance, which makes our unknown value normal. And that's it. Now, finally, when do we use kNN? So first, just like what we had as our example, the data must be labeled. Second, the data must be noise-free. And third, the data must be small. And so, that includes my discussion about kNN. Hope you guys learned from it.